So on Monday we talked about sodium borohydride and lithium aluminum hydride. So sodium borohydride reduces aldehydes and ketones, whereas lithium aluminum hydride is much more reactive, so it can reduce aldehydes, ketones, esters, and carboxylic acids. So if we take a look at question 13.12 part F, where we have this ketone and we have an ester in this molecule, and if we treat that with sodium borohydride and methanol, well, you can see from above, and what we talked about the other day in class, sodium borohydride can only reduce the ketone. It's only going to be able to reduce the ketone. So it cannot touch the ester. It can't touch that because it's not strong enough to reduce it. So what are we going to get as a product? We're going to generate an alcohol, and we're going to have our ester intact. But what if we tried to treat that same molecule and we treat it with lithium aluminum hydride? Well, it says up here that lithium aluminum hydride can reduce, let me get my green here, it can reduce the ketone and it can reduce the ester. So what are we going to get as a product in that case is we're going to get our, we're going to get our secondary alcohol, so we'll draw that. But also we're going to end up reducing the ester as well, and we're going to generate methanol as a side product as well. So we're going to be able to reduce the ketone and we're going to reduce the ester. And like I pointed out in our class notes, that it's important to include that methanol as one of the products that's formed from that reduction as well. You need to be detailed when you're doing these kinds of reactions. So you don't want to leave out those kinds of details. So if you take a look at question 13, so this is actually question 13.13. If you were to treat this ester, when you have a cyclic ester, this is actually called a lactone, but for this class we'll just call it a cyclic ester. When you treat that with excess lithium aluminum hydride, what's going to happen? Well, let's draw it out and see what happens when we treat this cyclic ester with lithium aluminum hydride. So first we're going to get attack of the hydride to our carbonyl. So what we're going to end up with is something that looks like this. So we're going to end up with our alkoxide. We're going to have our oxygen here as well. And what's going to happen is because we added that hydrogen atom, so this is the hydrogen atom that we added, and what's going to happen is this isn't going to be stable, so this is going to close, or excuse me, this double bond will reform, and then that's going to kick this oxygen out. So what we end up with is we generate an aldehyde. So it looks something, let me just clean that up. So we're going to generate this aldehyde. And this oxygen this is where our carbanion, or what do I say that? Our oxanion or alkoxide. So this oxygen is this one here. And now we have this aldehyde at the top. So what's going to happen is another equivalent, let me stretch this arrow, another equivalent of lithium aluminum hydride is going to do another reduction, and it's going to reduce the aldehyde this time. So it's going to attack here. So let me put in my lone pairs. So, and what we're going to get in that case, draw this out here, let me clean it up. We're going to end up with this. We're going to add another hydrogen. So we're going to regenerate, and we're going to actually end up with a dianion. So that's second equivalent of lithium aluminum hydride, and we end up with this dianion. And what happens is that we add enough acid at the end, so there's nothing else to reduce in our molecule anymore, and what we're going to end up with in the end is we're going to get our product, which looks something like this. So I'm just making sure I have everything intact. So this is what our product is going to look like. It's going to be a diol that we ended up with by treating this cyclic ester with lithium and aluminum hydride. That would make a great kind of question for a quiz or an exam or something like that. Excellent question.